Hey y'all, happy Friday. Sorry I'm not able to be there with you, but we're still will continue with our lesson. So this is going to be day 2 of finding our area of composite figures. So here are some reminders. So make sure you understand the difference between your radius and your diameter. Remember, your radius is from the center of a circle to the edge, and your diameter is from edge to edge. Now, I've also made sure to have our reminders here for finding the radius, diameter, our circumference, and our area. And since we're still looking at composite figures, I provided the star reference formula for your areas. Now, what is a composite figure? A composite figure is a geometric figure composed of 2 or more shapes. Now, sometimes when we're looking at composite figures, we're stepping it up a notch. You might see a shaded and an unshaded area. And so when we're looking at composite figures that include both a shaded and unshaded area, for us to find the area of a particular point, we need to make sure we choose subtraction. And let's go ahead and get started so you can see exactly what I'm talking about. Now, here's a quick example. Please make sure you're going to stop and take notes here to make sure you're looking at every single step. So this question says how to find the shaded area. So I'm looking at everything that is like a grayish looking color, so that shaded area. The very first thing that you want to do is identify the shapes that make up this composite figure. So we see a circle and we see a square. Now, you will then calculate, and for us to find the shaded area, we are going to subtract our shaded minus the unshaded area. Let's get started. Here's our very first practice problem. We're going to determine the shaded area. The very first thing you want to do is identify the 2 figures that you see within this composite figure. So if I'm looking here, my shape that I see includes a circle and a rectangle. I'm going to put rect for rectangle. So now the formula that we want to use will be area equals our pi radius squared. And for our rectangle, we know that's area equals base times height. So let's only now start to look at the circle. So if I notice that my circle from edge to edge in here in this rectangle kind of lets me know that my diameter is 10 centimeters. This is my diameter. But I need to find the radius. So that means I want to take that diameter and divide that by 2. So this will now be 3.14, which is our pi, times 5 squared. Now, if you want to see this written out more, this will now be 3.14, our pi, times 5 times 5. Once we solve that, we will get 78.5. Now that's for our circle. Let's move to our rectangle. Our base times our height. So 6 and 8. My base is 8 and my height is 6, which gives me 48. So now I'm going to subtract the shaded area, which is my circle, minus my rectangle, my non-shaded area. Minus 48 in individual 0. So once you subtract that, your final answer will be 30.5 centimeters squared. Okay? So we identified our 2 shapes. We did our formulas, calculated the formulas, and subtracted our shaded from our non-shaded area. Here's our next practice problem. we're still looking for the shaded area. So the two shapes that you should see, your shapes, you should see a rectangle or a square. Let me say square. And you should see a circle. And so we're going to solve. And so for our square, we know our base times our height. So 12 times 12 gives us 144. Our circle is 3.14. And that radius, because this from edge to edge lets me know that edge to edge that my diameter is 12. So I need to get half of that. So I want to divide that by 2, which will now leave me with 6 squared. So 3.14 times 6 times 6, which will give us 113.4. Now I need to subtract. So I want to subtract my two numbers. We're going to do subtraction. And so your final answer should be 30.96 meters squared. All right, cool. Now, sometimes you might see your composite figures with two circles together. So two circles that share the same center are known as your concentric circles. So we're going to be trying to solve to find that area of the shaded region with those concentric circles. This is how you calculate the area of shaded regions with your concentric circles. It's still doing the exact same steps, and we're just now making sure we understand that radius and diameter. So here I have an image. So these are your concentric circles. So two circles. If you notice, they both share the center. Let's go ahead and start some practice problems. So this here says determine the area of the shaded region. It says present your answer in pi and using actually solving with 3.14. Right now we're just going to solve it. So the first thing I want to do is I want to identify my two different circles. So I'm just going to name one as circle 1 and then circle 2. So I could identify two different circles. So I'm going to say circle 1, C1, and then I'm going to do C2. So for C1, for our very first circle, this is area equals pi radius squared, and we're doing the same for both because they're both circles. So if I'm looking at my circle 1, so that's the one I placed in the center, that radius is 2. So pi, erase that, 3.14 times 2 squared, which will be 3.14 times 2 times 2, which will give you 12.56. That's our first one. And for our second one, we have 3.14. This radius is 7 because this is from center to edge. 7 squared. Which will give us 153. 83. And so I want to still find the area of that shaded region. So I need to subtract the shaded area minus the non-shaded area. Make sure you line up your decimals. which will give you your answer of, I don't have nowhere to write it, but 141.30 feet squared is your final answer. We found the area of both. We're going to subtract because we're looking for the area of the shaded region. Okay, and now here I would like for you to go ahead and practice. Okay, perfect. Your final answer should be 122.46. Let's go ahead and continue. Now you want to determine the area of the shaded region. Now please be aware for this one, we have edge to edge, so this is our diameter. So if you have your diameter, but we're looking for the radius, what should you do? Okay, and so I will provide you with my exemplars at the end so you can see how I work these out. Now, sometimes when we're still looking for that area of composite figures, we're going to do the exact same steps, but sometimes it might not ask you or tell you which one you want to do. So if you're looking for one that includes shaded area, you want to subtract. If it does not have a shaded area, you will add. So here's our very first problem. A diagram of a garden made up of a triangle and rectangle is shown below. What is the area of the garden? So you see two different shapes, your triangle and your rectangle. So area equals base times height, divide that by 2. And area equals base times height. So let's look at the triangle. Our base, because we want to turn this to make it look like a 90-degree angle. Our base is 3. Our height is provided here, which is 5. Divide that by 2, which will give us 7.5. And now we're going to base times height. So 14 times 5 will give us 70. Because there are no shaded areas, we're going to add. No shaded areas, we're going to add. So your final answer will be 77 and 5 yards. Let's continue. So this here asks, what is the area of the shaded region? So we know at the very end, because it's shaded, we need to subtract. So you should see a triangle and a square. You're going to go ahead and solve your final answer. You should get D. Now here it has 4 semicircles. It is not shaded, so it's unshaded, so we know we're going to add at the end. But remember, you have 4. So your final answer is H.